So we'll take a little look at how we find the derivative of the natural log function. So if we have a function f of x and it's equal to the natural log of x, our maths formula book tells us that the derivative of the natural log of x is 1 over x. So that's pretty easy to understand. If we have something that's a little bit more complicated, so if I have the natural log of x plus 3, well, we apply the rule in the tables for the derivative, which is that it's equal to 1 over x plus 3. So the natural log of the bracket is equal to 1 over the bracket, but multiplied by the derivative of the bracket. Now in this case, the derivative of the bracket is just 1, so that's going to be 1 over x plus 3. What about if we have a function, the natural log of 2x minus 4? Well, the rule in the formula book says that the natural log of the bracket, that becomes 1 over the bracket, multiplied by the derivative of the bracket. The derivative of the bracket is 2, so that's 2 over 2x minus 4. So just a quick look at how we find the derivative of the natural log function. What I wanted to keep in mind for the second part of the question is this idea that if we differentiate a function, we can then do the reverse. We can integrate to get back to the original. And we don't have integrals of 1 over x and 1 over x plus 3 and 2 over 2x minus 4 on the course. And so this idea of integration and differentiation being the reverse of each other is important for the second part of this question. Okay, so let's see what we've been given. So we have that the h of x is equal to a half on the natural log of 2x plus 3. And then we have a constant here as well. And we know that when we derive a constant, we just get the number 0. So h prime x equals, well, the half is just a constant out in front of the natural log of 2x plus 3. So we're going to apply the derivative now of the natural log of 2x plus 3. So it is 1 over 2x plus 3 multiplied by the derivative of the bracket, which is 2. And then the c just goes to 0 when we derive it. And so h prime x is equal to, we divide above and below by 2, and we just get 1 over 2x plus 3. And this idea, again, that differentiation, integration of the reverse is so important for the next part of the question, because if I integrate this function, which ordinarily I wouldn't be able to do, I know that I would get a half on the natural log of 2x plus 3 plus c, because it's the reverse of differentiation. Integration, differentiation are the reverse. So ordinarily I couldn't integrate this, but I can because I know what the original function was that was derived to get this. So let's have a look at the second part of the question and break down what's going on. So we have our function here. So this is the function h prime x, which we know now is 1 over 2x plus 3. I'm just going to write up the original function here as well. So h of x was equal to a half on the log, natural log of 2x plus 3, and then plus c. And when we derived it, we got this function, which we've now drawn the graph of, which we have the graph of. We can see that there is a shaded region here between our function 1 over 2x plus 3 and the x-axis from x equals to 0 up until x equals to a, and we're told that the area of this is equal to the log of 3. So the unknown in this question is the a, like how far along the x-axis does this shaded region go, that it would give an area of log 3. So in functions and graphs, we know that the area between a curve and the x-axis can be found by integration. So if we integrate the function h prime x dx from 0 to a, we actually know the answer to this. The answer is log 3. We know the integral of h prime x because differentiation and integration are reverse processes. So ordinarily we couldn't integrate 1 over 2x plus 3, but we can because we know that it's a half on the natural log of 2x plus 3 plus the constant of integration. Now, we don't need the constant of integration in this question because this is a definite integral. We have limits of integration a and 0. So I'm just going to put in the 1 over 2x plus 3 dx, and we know that that's equal to the log of 3. And then I know that the integral of this is half on the natural log of 2x plus 3. And I'm just going to put in this in a square box. I have to sub in 0 and a, and this would be equal to the log of 3. So the first thing I'm going to do is, the half is just a constant in this question, so I'm actually going to multiply both sides by 2. And so I'm going to say that the log of 2x plus 3, or the natural log of 2x plus 3 from a to 0, is equal to 2 log 3. And then I'm going to sub in my a and my 0, so we'll go up here to do this and give ourselves a bit of space. So the log of, now for x I'm subbing in a, so it's 2a plus 3. And then I'm going to subtract the natural log of 2 times 0 plus 3. And I'm going to let this equal to 2 log 3. Now, we have a rule in logs that says that if you have the log of a minus the log of b, we can join them, make one single log to whatever the base is. In this case, it's the natural log, the log of a over b. We divide the two terms inside the brackets. So I'm going to tidy this by saying that the log of 2a plus 3 over, and here we have 2 by 0 plus 3, so this is just 3, and that is equal to, now I have a natural log on the left here, now I have a natural log on the right, but I have this 2 in front of it, and there is another rule in logs that says that a number in front of a log can be brought up as a power, so I'm going to say that that's the log of 3 squared. And what I can do now is, I have the natural log of both sides, so that means that these brackets must be equal to each other. So those terms must be equal. So 2a plus 3 over 3 must be equal to 3 squared, which is 9. 2a plus 3 must be equal to 3 by 9, which is 27. 2a must be equal to 24, and that means that a is equal to 12. So a nice little question, again, based on this idea that differentiation and integration are the reverse processes of each other. Ordinarily, we can't integrate 1 over 2x plus 3, but because we know what the original function was that was differentiated to give 1 over 2x plus 3, we can just write down that the integral of that is the original function. We sub in our limits of integration, we were given the answer, the area in this case, and we solve for the unknown, that was a. So let's just delete this, have a look at it, and the way it's done on the slide. So again, integration is the area between the curve and the x-axis. If we integrate h prime x from 0 to a and let it equal to log 3, we'll be able to solve for a. We didn't have to include the original constant of integration because we had our limits of integration here. And again, the reason we wouldn't include it is when we would sub in the a and the 0, you would just end up adding a c and subtracting a c, and that's why we don't include the constant of integration when we have limits. They just end up cancelling each other. So the integral of 1 over 2x plus 3 was the original function, which was half of log 2x plus 3. In this example, I multiplied both sides by 2, and then I subbed in the a and the 0, and I brought the 2, the number in front of the log, up as a power. The log of 2a plus 3 minus the log of 3, we can just divide those, and then we let the terms inside the brackets of the log equal each other. So 2a plus 3 over 3 is equal to 9, 2a plus 3 is 27, 2a is 24, and a is equal to 12.